my section here. Here's an image. So I decided to do this image because I was actually working with a couple students from Italy, and they said about this cool area called Campobasso. I've never been to Italy, but it looked like a cool place. So I was working with them, and it wasn't directly on this project. It was with another project I work on. But I decided to go and look at some satellite imagery of this area. And you can see here, I found the latitude and longitude basically of the town center. But my question here is, and this is for student research, how can we take an image just like this, look at it, and what can we tell about this image? What can we tell about the tree cover in this image? It looks like a pretty urban area. I mean, there's lots of buildings, lots of sidewalks and streets, lots of brick and mortar, as we call it. But we do see trees, and we see a park here. Looks like the fountain, Fontanella. Looks like there is that. So what you see here is, what you're looking at here is this town center called Campobasso, Italy. And the red arrow that you see there is the location of a tree, one of the trees that was measured by some citizen scientists using the NASA Globe Observer Trees tool. So, but before we get into that, just think about this. You don't have to answer. You can put it in the chat, and if if you want to talk amongst yourselves in the chat, when you look at this image, what can you tell about the tree cover? What can you tell about the land cover in this? What type? It's hard to tell exactly what type of trees, but and what about the greenings? Can you basically tell? It's in Italy, so you have the latitude and longitude. What can you tell about the greenings? Meaning, you see there's leaves on the trees, the pine needles are green. Okay, so what season could you say it was? And you can really tell a lot. And this is hopefully some people will understand that you can do research projects just by looking at an image like this. You can find an image of your location around the world and say, hey, this is what it looked like. Say you have an image from 1935 or something, and then you have another image of the same location in 2021. Okay, you can do a lot with that just by looking at these two images. You can do comparisons, you can do contrasts, you can look at how the land cover has changed over time in that 90 years, 80 years, 90 years. You can look at how many trees are there, a lot more trees or a lot less trees. I would probably say there's thinking about that, there'd be a lot less trees because of all the buildings being built. And then was it taken at the same season? Greenings might be a little tricky. Just have to be able to look, because back then it was primarily black and white photos. So, but you'd be able to see if there's leaves on the trees, not necessarily what color they are. So it might be a little tricky, but you can tell a lot by looking at images like this. So here's what I did, and I have a video to showcase that on the next slide. But I went and I found that location in the Globe visualization system, and I've these top 3 images on the left, basically showing you in Italy where this location is, and then zoom in a little more, and then zoom in even further. And then these are a couple questions, a couple investigative questions that you can use to help guide your research. What can you say about the land cover in this area? What can you say about the trees in this area? Can you find globe data from this location? Can you find ICESat-2 satellite measured tree heights in this location? Okay, so then what you're looking at here on the far right, this image that kind of looks like the ones on the left, but this is from open altimetry. So the base map you're looking at here is from open altimetry. Okay, but what you see there, and we've talked about this before during webinars, what you're seeing here are these photons. Remember, ICESat-2 uses a laser altimeter system where it bounces photons off the planet. So we take the time, we calculate the time it takes the laser photons or LiDAR to leave the satellite, bounce off the Earth's surface, and come back again. And by measuring that time and doing that repeatedly, we're able to tell how the elevation of things on the Earth is changing. We can measure the height of things all over the planet. Okay, so what you're seeing here, the pink and the purplish dots, those are photons that actually left the satellite, hit the Earth's surface, and came back again. Now, we have ones that hit very close. They didn't have to hit the exact tree, and that's something that is really tricky, to hit the exact tree, but it hit an area just next to the tree, just adjacent to the tree, where there's also other trees, and we got building heights and everything. But what you're looking at here is this little graph on the bottom. This is from Open Altimetry, and it's showing you the tree canopy height, the average tree canopy height for this location. Because remember, when you're taking the exact measurement of a tree with a NASA Globe Observer, you're taking one tree observation. ICESat-2, when it sends the laser photons down to the ground, the laser pulse spreads out and you get about a return of about 14 meters. So meaning it's basically calculating that average for all the trees that fit within that 14-meter diameter footprint on the ground. So if you have a tree, if the tree that you measured was isolated and there was nothing within 14 meters or basically 7 meters radius outside of this tree that you took, it would return just that tree height. But if it hits an area where there's lots of trees, it's going to take basically that average of all the tree heights in that location, in that 14-meter diameter space. So I'm going to play this video for you where I'm showing you how, as a student and as a teacher, you can go in and grab the data from a map, even like Google Maps or Google Earth, and then the globe visualization system, and then as well, then look at the ICESat-2 data for Open Altimetry. So then you can take all that data and compare it. So here, let me start this now. Let's say you're given an image like this. This happens to be an image in Italy. And what if you wanted to do a student research project to determine what you can tell by just looking at this image? What can you tell about the environment? Basically, what can you tell about the trees? What can you tell about the land cover? Is this an urban environment? Is it a rural environment? Is it a suburban environment? What can you tell about the seasons based upon the latitude and longitude of this? Now, I happen to know the latitude and longitude of this area. But what I want to do as part of this research, I want to show you how you can just look at the globe visualization system and see if there are any tree height observations taken in this location. And then we can look to see if there are any NASA ICESat-2 height measurements in this location as well, using the Open Altimetry online tool. So we're starting with this picture. You know, at first you can say, you know, you can have a hypothesis. Well, I think all the trees here look like they're between, 20 and 25 meters tall. It looks like there's an urban environment here. And it looks like, it may be springtime or summer because there's lots of green in the trees, in the grass, in the vegetation. So that could be a hypothesis. So, we can expand upon that by looking at some more data. So let's jump to the GLOBE website, okay? And we're going to go to, under GLOBE data, we're going to go to visualize data. That'll take us to the GLOBE visualization system. So let's do that. So once we're in there, we're going to go first to this fourth square up top here with the 3 dots. And we're going to change the base map to satellite. Not streets, satellite. So here we have satellite map. And then we're going to back out of that and go to these 3 layers here, the far left square. We're going to go under biosphere, under tree height, and let's just click tree photos. Now, while that's loading, remember this first picture was of Italy. So we're going to find that location. I happen to know where that is once again. And if you have taken a tree height observation in areas, you will be given the latitude and longitude of the tree location. So I'm going to zoom in here to Italy, all right? And the location that you see on this is going to match up with this image right here. It looks like a tree height observation from this area. So we're going to zoom in. And you can see this right here. It falls within this area that we're looking at, okay? Now, what we want to do here is we want to look and see where this tree is, okay? You can see on the map where it is, but if you click on the actual photo, you're going to get this information. The measurement tab will tell you what the height of the tree is. This happens to be 5.17 meters, okay? And then you have some comments here where it was. Villa Piazza Vittoria Emanuele, Okay, that's the location that was put in by the observer under metadata. You can see there's several data counts here. And then we're going to go in site info, and that's where we get the latitude and longitude. So once we have that latitude and longitude, we can then go to the Open Altimetry page and put that information in. So we go to Open Altimetry, that's openaltimetry.org. I'm going to click on the red rectangle that says Browse ICESat-2 Data. And on the left side, you can exit out of this. On the left side, you can see there's an arrow just below the magnifying glass. Click on that. And then you see center map on a point where you can input the longitude and latitude. So if we go back to the globe visualization site, and we're going to highlight the longitude first, copy that. You don't need the degree symbol. Go back to Open Altimetry, paste that in longitude, and we go to the latitude, do the same. Go back in Open Altimetry, and then we click Update Map. It'll center that location on the map. And if we go up to the top left, we can use the plus button to take us even closer into that same area. But what you'll notice here is that these red lines are ICESat-2 orbit tracks. These are important because this will tell us if ICESat-2 was near the latitude and longitude that we're trying to look at for tree height. So let's zoom in, and we'll click on one of these. Okay, remember, center of the map, the center of this map you're seeing here is the location you want. So we click on this orbit. We can click on these dates. We can see that ICESat-2 has been here. So we click on this one. No, that's not that close. Oh, here's one that's very close, right here. These pink and purple dots, these represent photons from ICESat-2 that have measured the height in this location. So let's exit out of, actually, let's zoom a little further here. Okay, to where these dots are. Make sure we update this map and keep it centered. Update the map. All right, you can see here that we're very close to the tree that was measured in globe. So let's back out of this. And what we want to do here is we want to go up to the top left under Open Altimetry where it says Select a Region. Click that, and then you can come over and you'll see this hatch mark or this plus sign, and you can hold the mouse down and drag a box around this area. Now, it doesn't look like the exact tree was measured, but there are lots of tree height measured in this location. So you can help, understand and focus on your hypothesis from this original image based upon what you see here. So let's click on View Elevation Profile. So what we're looking for are canopy heights. The top part, what you see are the elevations, the ground elevation and canopy surface. So what the elevations are for the area you're looking at. But then we'll see canopy heights. And each one of these photons here represents a tree height that was measured. So as you can see, there's been a bunch. So remember, in the original latitude and longitude from globe, let's look at the latitude, 41.5574 degrees. Let's see if we can match that up on Open Altimetry. Here we have 41.555, getting close, 556, 557, 557, okay? Here we have some that are very close. So let's click on this one here. We'll scroll over it. You can see canopy height for here is a little taller than what we saw on globe, so it's not the exact tree. But you can see the latitude is very, very close, 41.5573 to 41.5574. So very close. So it's a tree that is very nearby. So based upon that, you can then look at the tree heights for this area. You can see if your hypothesis was correct. You can then use all this information to look at this image even closer from the original image you see, and then any images you can see on Open Altimetry, and images that you can see on the NASA, the globe visualization system. And by combining the information that you get from all these images, you can develop a research project explaining how you can look at images on 3 separate systems to determine what that local environment is, whether it's an urban environment or a rural environment or a suburban environment, what the tree heights are like, what the land cover's like, what the greenings are based on seasonality. So I wish you good luck. And this is just one way that you can look at doing a student research project as part of the Trees Around the Globe student research campaign. Thanks so much. All right, so I hope that was a fun little explanation into how you can use these 3 different examples, from the the globe visualization system to just looking at a simple map like on Google Maps or Google Earth, and then also the open altimetry data. And that's one of the things that we like to do at NASA, is we like to try to figure out what's happening in a local environment to understand the global picture, but by looking at a combination of the ground-based data done by citizen scientists, done by researchers in the field, okay, professional researchers who, write papers, do research, things like that, and then compare all that to like the satellite data, specifically from ICESat-2. And there's lots of other satellites out there like Landsat and Aqua and Calypso, looking at clouds. So there's lots of other, CloudSat, lots of other different satellites out there that are doing these things. So that's one of the things we like to do. So hope this helped out a little bit for this. It's pretty easy to do, pretty self-explanatory. Does anybody have any questions on this part?
Hey, Brian, you do have one question in the chat from Anna. Yeah. Right before you got to the graphs, there's one point where she's asking, what do the different colors of the dots represent in open altimetry?
Yeah, so the dots, Anna, the dots are the actual laser photons. So when the ICESat-2 fires off the photons at 10,000, well, the fire laser pulses at 10,000 times per second, okay? What those colors represent in those 10,000 laser pulses, there's photons, since it's lasers, light, okay? The colors represent the photons that are hitting. Now, they're just different color-coded because essentially there are 6 beams. There's actually 3 beams from ICESat-2 tracking at a time, but each beam is split up into a pair. So it comes down to, it's actually 6 beams. So each beam pair has specific, color-coded colors on open altimetry. That's just how we reference them. They're the different satellite beams representing the photons that are coming back from ICESat-2. And these photons are what we time leaving the satellite, bouncing off the Earth's surface and come back to the satellite, so we can then determine what the height is of whatever it measured, whatever that photon hit and then came back to Earth. That's what the colors represent.